Hi and welcome to our program. Today we are visiting Cine Museum. Let's check out what Jens and Emma have to show us. Let's go.
Yeah, so the exhibition in here is more focused on astronomy, and we try to very often, both for normal visitors and the school classes, to include some kind of like artifact that they can interact with and so on. And that is a bit difficult with astronomy because, you know,
it's not here.
Very far away and not able to get it. However, we can do it somehow, either through some artifacts, I'll show you some in the minute, or photographs. Or in our planetarium, where we get to later, we can recreate the night sky and then use that. But for example, if you look at the wall over here,
this is so beautiful. Like
yes, we have very fancy pictures.
So beautiful.
And what we use this to illustrate is the birth and life and death of stars, and try to make. Can you
go through it?
I can go through it. Yeah. So you start over here with a giant. Interstellar gas cloud, like the two foundation building blocks for stars is gas and dust. So you have all this, and at some point it's going to start contracting. It gets hotter and hotter, denser and denser, and at some point you get a star that's formed. And it's this entire step ladder that we try to explain to the students and the visitors. When that forms stars, it's not just an individual star, but often a lot in combination. You get this, which is like an open cluster, it's called. So a lot of stars, generally same age, made of the same chemical composition.
So very similar in all aspects.
And similar. So same age, same place in the galaxy, consists of about the same thing.
Okay. Yeah? And how long does this procedure, that takes?
Depends, but somewhere like 100,000 to tens of millions of years for this to become that.
Yeah. Also, only the first step.
That's just the first step. Yeah, and stars, well, they're born and live and die, but how long it takes depends on how big they are, how massive they are when they're formed. So that's why it kind of splits up. And you have, for example, this is what our sun ends up doing.
Okay.
Ends up in something called a planetary nebula.
Okay.
Whereas more massive ones turn into this track up here, where we depict a supernova, with some of these very spectacular events where a star explodes, collapses and then explodes. And yeah, if the star is big enough, you can get this one. You might recognize it. It's the only photo we have of a black hole. It was discovered in the fall of 2019. It was in the news and stuff there. Yeah, it's pretty recent. Yeah, it's the only one we have. And I'd like to ask the question. I can ask it to you. Do you then really think it is a picture of a black hole?
No.
No?
No, because I think this is so complex. Like, how can you even get a picture of it? But I think that before we asked the same question about this, and now there are pictures of.
Well, black holes are, of course, the idea with them is that they have a gravity that's so high that they pull in even light, and light travels at a speed that sets the absolute speed limit for anything in the universe, and when that can't escape, nothing can escape. So what I like to think of it is actually kind of the shadow of a black hole, because you have some material around it that spins, and that means it hits itself, and that means it gets hot and sends out light, and that we can see. And then somewhere in the middle is where the black hole is, and you can't see that, but you can see kind of the shadow of the black hole here as this black region.
Yeah. And then what are the things around it? If the black hole pulls everything, why doesn't it pull
Well,
that
it's
part?
in the process of something in. It's what we call an accretion disk.
It's temporary. It will go.
Eventually, it will. Yes.
Okay.
Yeah.
Okay.
So, but it's all these very big thoughts and abstract concepts which we try to convey to students and visitors. But and again, that's difficult. Yeah. And one way we could also try to illustrate at least the aspect of gravity, that is the first step of why this pulls together, are these milk cartons. Okay. Where you can see what a liter of milk would roughly weigh when on a different planet here in the solar system.
Okay. Yes.
So because the
so this all weighs the same in here.
You have a volume of 1 liter that would weigh differently depending on what the gravitational potential is. So yeah, Jupiter, very big planet, that becomes heavy.
This is heavy.
Yeah.
This one is really
That's
light.
Mars. Mars is smaller than Earth, so it'll be lighter. Yeah. Uranus, I think it's also a bit heavier than Earth.
Yeah.
Yeah.
Cool.
One thing I like to show the students is this one, which is a meteorite from somewhere in Russia, a Russian mountain chain it fell down in. And yeah, when they fall down, they all get classified according to what their composition is, what they're made of, out of. And then afterwards, you can then actually buy them and distribute them. And you can try and hold it if you want.
Okay.
It has this very smooth surface.
This is really heavy.
Yeah, it is. It is kind of heavy.
Wow.
And it's also magnetic. So. And yeah, how old do you think that thing is?
It smells like
Yeah,
iron.
metal. What?
It smells like iron.
Yeah, they do contain a lot of metals. How old do you think what you're holding is?
No idea.
Do you know what a meteorite is?
Yeah, it's when a corpse, I don't know the expressions in English, like
No.
when kind of a planet or solid, let's say, comes like is pulled
Yeah.
through gravity.
It's
from Earth.
well, it's all this gas and dust that we had over here forms a star. Some of it doesn't get into the star and lays kind of around it as this disk that we talked about, and then that becomes planets. And again, some of it doesn't end up in the planets. And you have leftovers, which forms asteroids, which are just space rocks flying around. And we get hit by them all the time. And when they hit the Earth's atmosphere, they heat up incredibly because of the friction. So what I like to do with the small classes is if you slap your hands together and do that, it gets warm, you know. And that's very easy for the children to understand. That gets warm. That's what this feels to an extreme degree.
Yeah.
So that is what a shooting star is. And then we can go up and pick it up. But because it's made from leftover gas from here, this thing is as old as the sun. So you're holding something that is 4.6 billion years old. Older than as old or older than the Earth. It's incredible. Like it's much
so
older
weird.
than anything you can find.
It's so small.
So try to convey to the visitors how I find it so mind-boggling that you can actually hold something that's that old.
It really is. And I would also like to ask you, do you get a lot of questions like what will happen when the sun will hit this stage of
I tend to actually go there myself and then try to explain what happens. Yeah, and that is exactly what stellar evolution is. So when the sun is nearing its end of its life, in about 4 billion years, it'll swell up and become what's called a red giant. And that means actually that the surface of the sun will be somewhere between Earth and Mars, so outside of Earth's orbit. So the Earth will actually be inside the sun and completely burned to a crisp and gone. So it's like a final deadline to get away. Yeah. But we're not here. In 4 million or 4 billion years, we have plenty of time.
Still, it's there.
It's gonna happen eventually, inevitably. Yeah. So we also work a lot with light and how when you study astronomy, the only thing you have to work with is the light coming from whatever object. So here, for the example, the sun. This is a live feed from the Solar Dynamics Observatory that's driven by.
This is live feed.
It's a live feed from the past 2 days of what the sun's surface looked like. It's driven by NASA, and it's just a telescope that always points there. Okay. And you see all these funky structures.
I was going to ask what are these things?
Yeah, it's called geomagnetic storms.
Okay. So there are storms in the sun.
Essentially, yeah, not very well understood. But as we also illustrate on the wall over here, how looking at different components of what light is, you see different things. So this is how you imagine the sun, as this nice red surface. But then suddenly when you start looking at different wavelengths, as it's called, you see structures coming into
Okay. So this is all the sun.
It's all pictures of the sun, yes, just in different light, like different wavelengths of light, as we say, and then we see different things. So how astronomers we use the light to in every aspect of what light is in order to try and learn about the mysteries of the universe, really.
So weird. Everything comes out to. Yeah. And you also have the solar system
Yes, that's for the small like a little exercise I like to do with small classes that are in here is like pick your favorite planet and go stand on it, and then you know someone standing on Mercury, Venus, Earth over there, so on, and then you just.
Jupiter is so big.
Jupiter is a very big one.
Yeah, but like, you know it, but when you actually see it, it's like.
Yeah, that's not even to scale. It's way bigger. It's huge.
My God.
So yeah.
It is cool.
Yeah.
And what is this?
That's kind of an illustration of a space capsule or like a replica, and it just kind of shows how this friction that meteorites also experience chars the outside of the shielding of such a capsule when it re-enters Earth's atmosphere.
Okay, so this is the friction.
Yeah, it basically friction like burns the friction causes a lot of heat that leaves these scorch marks.
Okay.
It's a replica from the of the capsule from where the Danish astronaut, the only Danish astronaut who'd been at the International Space Station when he returned. It's a replica of that one.
Ah, that's cool.
Yeah.
And what about this?
Well,
or maybe this before?
Yeah, this one is an illustration of something that we do up at Aarhus University, actually. We simulate the Martian like weather conditions and atmosphere. So basically take some very fine-grained dust you can push, not a lot happens. You see, it's a wind gauge.
I was expecting.
Exactly. But it's
more.
Up at Aarhus University, we've actually developed the wind gauges that are now located on the rovers that are on the surface of Mars. So NASA sends the components, and then we test them to see if they can actually endure the Martian environment.
Okay.
So
That
this is just a small.
complex.
It is very complex, but that's just a small. We have it's a big pressure chamber like this, and you put the machine in there, and then you try to see if it survives.
Wow.
Yeah.
Do people go inside? That would be cool.
That would also be dangerous.
Ah, okay. Never mind.
Yeah. And yeah, some models of what exoplanets look like, what we imagine some of them to look like.
Okay.
And yeah, it's all that's very on the edge of research, like how we can try and model exoplanets and so on.
Yeah.
And that's difficult to teach the children. At least it's the higher grades, like the older ones, that we can start talking about this.
Okay.
So.
And what is this machine doing?
It illustrates one way that we find exoplanets, called the transit method. So if you see that we receive more or less constant light from a star, and then a planet moves between us and the star, we get a dip, and it moves away again. So depending on how deep this dip is, how long time it takes, so on, we can try and estimate how big is the planet, how far is it from the star, so on.
So interesting. Everything is like, you estimate everything.
Oh,
You're
absolutely. Yeah. It's not. We try to do it exactly, of course, but it's difficult.
Yeah.
And yeah, this one's just really nice to illustrate the different planets. So when I present them for the children, it's just, and we go to Mars, I get the teacher to put up Mars, we go to Jupiter, so on.
Okay.
Yeah, exactly. You can see the different ones.
Wow.
That was a bit, Uranus is a bit boring. So is Neptune. But yeah.
It's all the same color.
Yep. I guess we can go to the planetarium as the next then?
We can go upstairs.
Yes, great. but I don't think you'll see much. Jeg kan bare lukke døren. Bare luk døren helt af.
Yeah, now we are just trying to see how it looks in the camera.
It's gonna get a little dark then.
Yeah. You cannot see anything, can you?
Your eyes are gonna adjust more and more. Normally it takes like 10 to 12 minutes to get your night vision up and going. So right now you don't see much, but a lot of stars are gonna come up soon.
Yeah.
But I'm not sure you'll be able to see anything with the camera.
Yeah, how is it there? Look one? Nothing, yeah.
Yeah, no, I don't think you can.
Yeah, that's too bad.
Yeah, but I can put on the lights and make it a little bit cozy, and we can talk about, you can see the machine in the middle at least.
Mm-hmm.
You can explain to you that that's the one making the sound.
Yeah.
Yeah, you can explain how the room works.
Yeah, definitely.
Yeah, but it's too bad that we cannot use it. Yeah.
More and more.
Yeah, so cool.
Normally it's much better like experience because we need to get your eyes adjusted to the dark, and it takes like 5-10 minutes while I slowly turn down the lights.
Yeah.
And you get a much better effect when you turn off the last light in here.
Okay. Yeah.
But more and more are coming.
And these talks that you have in the weekends, is it always the same topic or?
It's seasonal. So four different, pretty much around the year, like so spring, summer, so on. Just what is on the night sky that you can see right now if you went out tonight.
Okay.
And then also different like special topics in like the vacations if we have a certain theme or something.
Okay. Okay.
Then they're a bit more special.
Yeah, it would be super cool to have some programs on that, but yeah, we cannot have nice images, unfortunately.
How would you like the light?
Yeah, look one? Okay. Then maybe you can explain us what
Well,
what does this do?
I don't know if you wanted to, we can shoot an introduction afterwards then, I guess.
Yeah, it's okay.
Yeah, well, what you see in here is our big planetarium where the idea is that we can recreate the night sky in a pretty much one-to-one replica, because we have this half sphere above our heads, and I can take you anywhere on Earth with a couple of turns of the buttons back there. With this ancient technology from the 80s here.
Ancient.
Our Skymaster. It's basically just a glorified lamp. There's like I think 8,000 different small light bulbs in here.
8,000.
Something like it, and then just.
But that's so small.
Yeah, and then just tiny like outlets that control where the stars then shoot out, and then it can rotate about a bunch of different like axes to portray them properly on the night sky. And we use this to show all the constellations and what stars you could see at a certain time, and how to navigate on the night sky. And also very nicely illustrates how light pollution is a problem for us astronomers. Such as right now, you don't see any stars because there's light all around the sides here.
But the stars are there.
They are there. They're on right now. I can spot Orion over here if you have a clean or good eyesight. But yeah, the talk of light pollution, for example, and you can easily just ask, well, if we need to go dark, where do you go? And then all the visitors will say, to the country. Yeah, sure. There's still a city nearby. If we want bigger thoughts, what are we going to do, and so on, and have a discussion with everybody involved, so they get a grasp of what is key when you want to study and look at stars.
Yeah. Wow. So this is live. Or like, do you update it once in a while? Like, how does it work?
It's just by the turn of the buttons. I can take you to August right now if I want, and then I can portray the August night sky. But we usually just have it set to tonight here in Aarhus, and then that is what you would see, an exact representation of the night sky if everyone could turn off their lights, not go into their car, and so on.
Yeah. That would be nice.
That would be very nice, but yeah.
So what type of events do you have in here?
Well, we have the normal bookings that schools come in here, and then that's an hour's show and whatever. And then in the weekends we have 2 showings per day. about the seasonal sky. So what do you see on the right now? It's the winter sky. What can you see? For example, Orion up there is a big part of it because he's easy to spot. And then we also have something like full moon events. So once a month there's a full moon, and then we also do some special like evening events for that. And it's the planetarium and also the museum is free for any student at studying at Aarhus University, so they can freely come in here and experience it.
Yeah, that's so cool. I don't know if you would like to add anything else.
I don't think so, really.
Is it possible if we show the?
Yeah, you can come
just
right
to see
around if you want to see.
How it works.
It's,
like
well, for one, we have a nice stereo system in here as well, so you can put on some music for the visitors.
Ooh.
That's that part. And then the Skymaster is controlled by the screen here and this board right there. So I can control what time it is, what latitude we're at, what the date and time is, and I can put on different planets, I can put on the constellations, so on.
Wow, that's so cool.
Yeah.
And this is a program?
Yes, it automatically boots. It's all set up, so it's nice and automatic.
It was all dark. But cool.
Yeah, so it's a little fun to have to work in the dark. Like you have to be able to speak and find and everything and walk around while it's completely dark in here. So that took some getting used to.
But then your eyes do all the work.
Definitely.
But cool.
Yeah.
Cool. So thank you so much for showing us around.
Of course.
Yes.
Thank you so much for visiting Steno.
Yes, of course. Thank you. That was it for today. Thank you for staying with us. We hope you enjoyed this program. See you next time.
In 2004, a new art museum, the Aros, has begun its exhibitions. Currently, among others, a special exhibition shows art pieces under the title of Fra Abigail til Kirkeby, which tell the story of the development of Danish art over 200 years with the odd glance of foreign works. Included the part of the nature and the realism, the modern breakthrough as far as the imagination and feeling, as the museum explained. It depends on us what we want to see. Definitely recommended to everyone. Aarhus is a dynamic city of the Jutland Peninsula in Denmark. 315,000 people live in Aarhus, one of the oldest towns in Scandinavia, established in 770 at the Viking Ages. Aarhus City Hall is designed in 1941, Denmark's new culture canon. The bell tower, which since then has become a landmark for Aarhus, stands 60 meters tall, including 43 bells which 3 times a day play the song Invernalis Temporis. With a length of 93 meters, Aarhus Cathedral is the longest church in Denmark, the result of radical rebuilding in Gothic style, and it seats approximately 1,200 people. Nearby the cathedral, we can see the bronze horse memorial statue with Danish King Christian X, which made at 1955 by K. Fisher. The Spanian, the oldest swimming pool place in Aarhus, was built between 1930 to 1933 at the heart of the city. Here you can enjoy the swimming, massage, fitness activities, relax at the cafe, and so on. Den Gamle By was founded in 1909 as the world's first open-air museum of urban history and culture. 75 historical houses from all over Denmark shape the contours of a Danish town as it might have looked in Hans Christian Andersen's days, with streets, shops, yards, and some virtual interactive screens around the museum. Den Gamle By is an amazing historical experience for all of us. The iceberg was built at 2012 on the coast of Aarhus Harbor with perfect view to the sea. This extraordinary building complex includes 208 apartments made by 2 Danish, 1 Dutch and 1 French contemporary architect companies. Aarhus Central Station was built in 1927. The station is used by an average of 6.3 million people per year, making it the busiest station outside the Copenhagen area. There are intercity connections to Aalborg and Copenhagen, regional connections to the rest of Jutland, and international trains to Hamburg and Berlin. The river Aarhus, what is known today as the Vodested, with its coffee culture and outdoor life, especially during the summertime, with the circle of bridges, historical places, a very vibrant and busy place. Aarhus Theatre opened in 1900 by architect Huck Kampmann. Every year, 450 shows from 20 amazing different stage pieces for approximately 100,000 spectators. When sun goes down, we can explore the nightlife or just relax in hotel. It's up to us. And when next day comes, we can explore again and again this amazing place, which called the City of Everything.
Ungdomsradio. Ungdomsradio. Ungdomsradio.